Next, we want to link or constrain the meshes to the joints. We could directly parent the meshes to the joints, but then if we, for example, put the joints on a layer and hid them, we would also hide the meshes. Visibility is a property of the object's transform node, and it's inherited. That means that the child will be hidden if the parent is hidden. To avoid this and some other minor nuisances, I'm going to choose to parent constrain all of the meshes to their respective joints. And parent constraints act just like parenting. However, they give you the additional ability to turn specific transforms off, for example, to only rotate and move in certain axes. In this case, we're just going to use parent constraints in order to get around this visibility issue. To create standard parent-child links, as you probably know, you select what's going to be the child and then select the thing that's going to be the parent and press P. For constraints, it's the other way around. You need to select the thing that's going to be constrained, or the follower, or the child, last. So in other words, you select your parent object, or what's going to be the parent, first, and then you select what's going to be the child object, or the constrained object, last. That's because you're applying a constraint node onto, in this case, for example, the meshes. Each mesh in the rig needs to be constrained individually to a joint. Let's open up the robot mesh group. And in order to make it easier to build our constraints, we should name all of the joints. So let's do that very quickly. The first one here is the swivel joint. I'll call it joint swivel. Joint 2 is the shoulder. Double click and rename. Joint 3 is the elbow. Joint 4, the forearm. Joint 5, the wrist. Joint 6 is finger 1. Joint 7 will be finger 1 end. Joint 8 will be finger 2, and joint 9 will be finger 2 end. Now that I've renamed everything, it'll be a lot easier for me to build these constraints. Selection in the viewport is kind of problematic, so I would recommend using the outliner. Swivel is going to be constrained to joint swivel. Once again, we select what's going to be the parent first, in this case the joint, and then select the thing that's going to be the child. Control click on Robot Mesh Swivel. Go into the Constrain menu and choose Parent Options, and just reset it. Go to Edit Reset just to make sure that all Translate and Rotate axes are enabled, and then Maintain Offset is on. Click Add, and then in the outliner we will see there's a plus sign next to Robot Mesh Swivel. Open that up and we see a constraint node. We don't need to do anything to that constraint node. We're finished with that. If I now select Joint Swivel and then rotate it, we will see that the mesh rotates with it. Undo that rotation. And simply go down the line and link the various parts. You will see that there are some variously named objects here. And for example, we need to investigate here. This one is labeled as wrist 1 and this is wrist 2. But in fact, on further examination, we probably don't want this object to rotate. It should be part of this forearm mesh. We can link each of these individually to a bone or a joint. We just need to figure out which ones are going to rotate and which aren't. This one, in fact, is not a wrist object. I want to actually make it forearm too. So just a little bit of detective work here. Sometimes you need to suss out issues in files. That's going to be forearm too. And then this one is just going to be wrist, period. Okay, now we can figure this out. We want now to parent constrain the shoulder to the shoulder joint. Select joint shoulder, hold down Control, choose Robot Mesh Shoulder, and constrain parent. Test it. Grab this shoulder joint and rotate it. Looks good. We just repeat that process. Joint elbow, Control, and we have two parts this time, elbow 1 and elbow 2. Elbow 2 is this little piece. We need to do them individually. I don't need to keep going up to constrain parent because I can just use the most recent command. The hotkey is G. Once again, select joint elbow, and this time control-click mesh elbow 2 and press G. And that created a constraint node there. Select the joint rotation, test it, and both of those meshes are moving. They're both assuming the rotation angle of that joint. Okay, so the rest is pretty easy here. Joint forearm, control-click robot mesh forearm, and press G, and then joint forearm, robot mesh forearm 2, and press G. Joint wrist, control-click robot mesh wrist, and press G. Finger 1, and G, and finger 2, and G. And I've created all the constraints. I can now test these. The robot meshes are all on their own layer. That means that I can reference them and not be able to select them. That's a good idea. I can click here, it'll say T, and then click again, and it'll say R, meaning now it's referenced. We can't click on it directly. Also, Maya will always give priority to joint selections, meaning that if you have joints and meshes in the same location, Maya will give selection preference to the joints. Okay, let's test it. Select the joint and rotate it, and it looks like those meshes are following correctly. So our next step is to figure out which rotations are valid. For example, this is not a valid rotation for that object. I can only rotate, in this case, around Z. We want to sort out the degrees of freedom, and that's found in the joint attributes. Select a joint and open the attribute editor with Control-A, and you'll see under joint, degrees of freedom. Now you'll only be able to see the effects of degrees of freedom here if you're in a special rotation mode. Double-click your rotate tool. Open up the tool settings, and you'll see rotate mode. Local, world, and gimbal. Local is actually a sort of temporary reference system. It's actually the parent rotations. World is, of course, the world grid. Gimbal mode is the true rotation space of the object itself. And in fact, you should usually create animation in gimbal mode because you'll have fewer issues. A gimbal is a set of interlocking rings. It's used in aviation, for example, to keep a compass level no matter what angle the plane is at. In this case, it gives us access to the native rotation space of the selected object. And once we're in gimbal mode, then if we turn degrees of freedom on and off, we can see effects here in the viewport. When I turned off X, it turned gray here. So I only want to rotate around Z, the blue one. Turn Y off. So as we see now, I can rotate in that one axis, can undo that, but I can't rotate in any other axis, and it doesn't even matter which mode I'm in anymore. So even if I'm in local mode and I click on Y, for example, it'll always rotate around Z instead. Undo that with Control Z or Z. But I do want to be in gimbal mode. That way I'll be able to see what I'm doing here. For each joint, I just want to limit the degrees of freedom. I only want to rotate around Y for the elbow. For the shoulder, likewise, only around Y. And the swivel down here, I want to rotate around X. And that's the local X axis of the joint itself. Up here at the top, let's select the wrist, and we only want to rotate around X in that case. And lastly, we can set the degrees of freedom for the finger joints. Close the tool settings. Just select the joint by selecting the bone that projects out from the joint. And here we can disable X and Z. Likewise on the other side, select that. We only need to rotate around Y. Our skeleton is set up now. We should also create a SuperMover, which is an object that is used to move the entire rig around. Do that in the top viewport. Go to the Create menu and choose CV Curve Tool Options, and set the curve degree to 1 linear, and just draw a curve or a square around the object. Let's turn on Snap to Grid. I'll go out here just at the corners here, 50 units away. I don't need to close the curve. I can just draw those 4 points and press Enter. Close it using the menus. Surfaces menu set. Edit curves. Open close curves. Rename it. Call it Robot Mover. And we want to link or constrain the parts to it. We can link joints just like any other object. I can select that joint and then select the SuperMover and press P and link it. If you have trouble selecting the SuperMover, you can do it in the outliner. Window outliner. So right now I've got Robot Mover has a child, which is joint swivel. I can undo that. I can middle mouse drag. And then if I drag onto nothing and get just a line there, I'm unparenting. So I can parent from here in multiple ways. Select the object that's going to be the child. Hold down Control, select the object that's going to be parent, and press P. Or we can drag and drop directly onto things in order to create parent-child links. However you do it, you want joint swivel to be the child of Robot Mover. And then we can select Robot Mover and turn snapping off. We can move it and you can see that the joints follow. The last thing we do want to do is also constrain or link this mesh object to the SuperMover. It's on a reference layer here, so I'm going to click until I see nothing here, meaning it's not referenced. Once again, I want to select what's going to be the parent first for constraint. And the parent here is going to be Robot Mover. Hold down Control-Shift and click on the mesh object in the viewport, and it should be lit up as the most recently selected object in bright green. And then we can go back to Animation, Constrain, Parent. And we can open that up. Robot Mesh Group. Robot Mesh Base now has a constraint on it. Go back to the SuperMover, just select it and move it, and now you'll see all the parts are following. Awesome, that is a great place for us to save. File save scene as. Files of type Maya ASCII. I'll call it robotanimation.0001.ma. And that sets that up for increment and save.